Welcome to Euclidean Geometry. For the next few lessons, we are going to live like we lived back in high school. I am wearing stuff from my high school as we speak. You should too. Show some school spirit. Go back to high school while we're in these next few lessons. This is high school geometry. Euclidean geometry. And so there are all sorts of things that are true in our Euclidean geometry. They were true in high school. They're true for us through these lessons in Euclidean geometry. Converse, the alternate interior angles theorem. If two parallel lines are cut by a transversal, by golly, those alternate interior angles are congruent. The rest of that screen is true. These are all true. We've talked about them in previous videos. In particular, every triangle has an angle sum of 180 in Euclidean geometry. There is no other kind of triangle. We're in Euclidean geometry. We're going to talk a lot about similarity because similarity is a very Euclidean thing. To say the two triangles are the same shape but different sizes is a very Euclidean thing. It is also true that if ABCD is a parallelogram, so parallelogram ABCD, then there are some things that are true. It is true that triangle ABC is congruent to triangle CDA. You can draw a diagonal and break the parallelogram up into two congruent triangles. It is true that AB is congruent to CD and BC is congruent to AD. That's a strictly Euclidean result. It's not neutral. It's a strictly Euclidean result. The fact that opposite angles are congruent. Angle ABC is congruent to angle CDA. The opposite angles are congruent. That's a strictly Euclidean result. By the way, all of these fall from that. Also, AD and that's not true. That's not true. AC and BD bisect each other. One of the results we carry to our course from our high school studies that the diagonals of a parallelogram bisect each other. It again falls out of congruent triangles, but that flows because we are in a Euclidean geometry. In neutral geometry, none of these things are necessarily true. So if we have Euclid's parallel postulate, then we have all of these things. So because we're in Euclidean geometry for the next few lessons, you can assume that all of these things are true. You can play with them. You can play with parallelograms knowing that these things are true. Okay? Next video gets us similarity the way we're used to. We'll do parallel projection up next.